TQCQ, Kilo 4 Sierra Delta Victor, Kilo 4, Sheriff's Deputy, Vance County, QRZ. Welcome to QSO. What a cop. Hey, good morning, good afternoon, good evening, YouTube family. Got a treat here for you guys from our friends over at Tactical Ham Radio Gear. Here we go, get that in frame and focus. Another bandpass filter. This time we're going to do it for 160 meters. Let's open it up, see what we got here. Alright. This is going to be a different board design. Let's see here, we'll open this up. Okay, here we have a parts list. We're going to have one PCB, 20 AWG enamel copper wire, 5 feet of it, 3 T94 cores, 1 die cast enclosure, 2 SO239 connectors, silver mica 500 volt 5% capacitors, 5 of them, band specific. Let's see, the following assembly order is for reference only. Fabricate the enclosure with 2 holes for the coax connectors. Let's see, 2 5/8 diameter holes. Use the PCB as a drill template for the coax connectors. Install the appropriate capacitors based on the band. Going to supply parts chart schematic. Okay. Alright. Okay. It seems to be pretty simple. So let's see what we have here to change. Okay. Enclosure. Nothing different about that. Let's put that in the trash. Now there was a PCB board design change. Put that in the trash. Dump that. Oh wow, neat. This is the new PCB board for bandpass filter that we're going to be building, but we're going to do ours for 160 meters. It's smaller, okay. Of course, Tactical Radio Gear made in the USA, veteran-owned business. There's our wire, a magnet wire. Okay. These are our silver mica capacitors. When the enclosure is complete, radio, I'm sorry guys, when the enclosure is complete, radio, antenna. However, it doesn't matter if you connect your radio to the antenna side, the antenna to the radio side. It completely doesn't matter. This is for operators that need complete total instruction and are truly afraid to mess something up, but it really doesn't matter as long as you don't tune into the filter with your radio's internal ATU. That's what matters. Alright, we got 3 toroids here. Alright, got our 5 capacitors. And of course, the SO239s that I love. I hate drilling holes for them. So these are the ones I really, really like. All right, so we're going to pause for a minute. I'm going to go, obviously, drill my holes for my SO239s, and of course, holes to mount the PCB. With that being said, we'll be right back. Catch you in a few. It's Tony. Welcome back. I was on my way to drill the holes for the SO239, but when I looked at the board, something clicked. This is totally designed different. And based on what the other boards look like, this is really different. And what I mean by really different is I'm going to set this down on top of the enclosure. I'm going to zoom in. And I'm going to see if you guys pick up where I'm getting at. I'm going to knock out these lights to kill some of the glare. Okay. All right. Remember how we did these in the past? This is going to be completely different. Why is this going to be different? We're going to drill our holes for our SO239s. They're not going to be on the ends. They're actually going to be here on the bottom. I don't know if you're following me, but follow along. Put that one there. Put that one there. Set our board on top. We will wind our toroids, and they'll be soldered in. And then we'll solder our capacitors in appropriately. But this is what our filter will look like. Now remember what I said. You know, this radio, antenna, radio, it doesn't matter. That's irrelevant. But this is what we're looking at. So one wire of our magnet wire will be soldered to the board. Capacitors go in their appropriate positions, but the other end of our wire will solder directly into our SO239s. So that is a neat approach, and it really gets everything to fit. And inside the enclosure, wow, I'm impressed. All right, well, let me go drill some holes. Well, let me mark some positions, drill some holes. So, in case you haven't figured it out, these SO239s will be down inside. Now, it's obviously it's not going to be that high because they will be protruding out the backside, and everything will just fit down inside here. Okay, so we're gonna go mark those, and I'm excited because this is something new. Chris has eliminated the need for standoffs because, well, backs of our SO239s are going to act as our standoffs. They're obviously going to be mounted to the enclosure, which is going to be a ground, and they're sitting on top, so that's going to complete the ground. He's eliminated some extra parts. So you just have to drill 2 holes, and that's it. You don't have to go back and drill holes for standoffs for the board, and then drill an additional 2 holes for your SO239s. You're just drilling 2 holes for your SO239s. I'm sorry if I sound overly excited, but this is actually cool because he's just eliminated 4 steps, which is 4 additional holes. So where it would have been 1, 2, 3, 4, 5, 6, he's taken 4 out, and that's amazing. So guys, I'm gonna go ahead and get this marked up, get it drilled, get our toroids wound for 160 meters, and then I'll be right back. Okay, we've got our holes drilled. Alright, something I want to talk about. When you put your SO239s in, your ground lugs, you want to bend them up. Not sure where you can see that on the camera, but they're going to have to be up. Now, this is what's going to happen. You're going to install the PCB so that it's 239s running through, and then that ground lug on each will be through the hole, because we're going to solder that ground into the hole. Now, what you're going to find interesting, I'm going to go through and I'm going to grab my meter real quick, just so that we can do something real quick so that this makes more sense. So we have continuity. Alright. So after we wind our toroids, we know that these are grounds. Touching the case shows that they are in fact grounds. Alright, so somebody wants to constantly shut the repeater and be a pain in the butt. Alright, so we have no continuity from here. Get this back in there. From here to here. Although if I touch the center conductor or center pin, we should have continuity from this spot to here. And if I touch it to the board, to the center conductor, okay. So it's going to be the same for this side. We'll have no continuity, but if we come here, just touching the center pin, okay, see there. So when you put your toroid in, you're going to solder one in there, on this side, one here, and of course the center one will be soldered there. So I'm going to go ahead and at this point I'm going to populate the board, putting all my capacitors where they should be, and then after the board's populated, I'll drop it back inside. I'll solder the 2 lugs to the board, and then I will attach the toroidal cores to their positions that they belong in. Alright, so stay tuned and we'll be right back. Okay, welcome back. Alright, your board should be populated. Should look like that. Ooh, excuse me. But all your capacitors are on here. So now what we're going to do is solder on our toroids. So I think I'm going to choose, and excuse me, before I solder anything on, see if I can get the camera to focus. I like to scrunch mine in as much as I can. So I'm going to solder that one to the center. We're going to use our trusty Kester 1/8/6 pen or bottle. I'm going to use the pen here. So it on the wire. All three of our toroids. What I like about the Kester, it's a no clean flux, so we don't have to go back and monkey with it anymore. You know, if you want to clean it, you can use alcohol. Don't just use any alcohol or 90% like store-bought alcohol. When you're using alcohol for your electronics cleaning, this is what I recommend: 99% isopropyl. Great stuff. If you get it on your skin, it'll dry your skin out fairly quickly. So try not to get it on your skin. Also, I'm gonna hit my pads. For this, once you have your board populated, okay, so we're gonna solder one into the toroid there, one there, one there, one there, one there, and one there. Alright, so pretty simple, pretty easy. I'm not going to use we're not going to use this bad boy because I really don't need it. Don't need anything to hold the board. But what I'm going to do is I'm going to get that into there, that into there. And I'm not going to solder from the top per se. I'm going to go from, we're going to solder from this side. So I'm just going to lay that down. Did that one jump ship on me? Yes, it did. Okay, and I'm going to get it, you know, in the middle of the room like it should be. Crunch those and dropped it, no big deal. Back where I need it. Crunch it in. Actually, I think this might have been, I think I might have made this for to go here in the center. Yep. Pull that down. We'll fix this one here in the center. And there's a little secret about the toroid that goes in the center. I'm just gonna lay that there for now. I'm just using that just to pull it close to the board, tight to the board. Get my toroid in a position where I want it. And we're just going to go ahead and solder that one on. Just for good measure, just a little 1/8. I know I hit it with the pen, but you know, little extra solder doesn't hurt, and it's no clean solder. So if you did not get all your enamel off of your toroid, that's going to completely burn it out, burn it away. So that you make sure you have, it'll make sure that you have a good connection. Alright, and I'm at 700 degrees on the iron. I'm actually going to tend this iron a little bit before we get in here. So, alright, I'm just going to drag it through. Okay, so we got our tip tend. Our tip's nice and tend. Our solder, and like I said, 700 degrees. My finger bumped at 701. That's going to be just fine. And we're, kind of doing this as fast as I can. I don't want to dilly-dally. We're using very high temperatures here. I just want to make sure I get good flow. Get good flow, alright. Grab our flush cutters. Now, I remember recommending these flush cutters in a previous video. They're from Walmart. They're like $3. I bought 2 sets. There's a saying, buy cheap, buy twice. Buy you a good set, rather than having a cheap set. And I like the back flush on my soldering. So there's our center conductor, or our center toroid. Let's go and let's put this one here. So when I say let's put this one here, it's going to go one there, one there. Alright. And just follow the little template on it. By the way, these dikes that I'm using are not sharp at all. They're not going to cut this wire. If anything, it'll scare the wire more than what it will actually cut it. So, there we go. Like that. Flip it over. And Kester's my favorite. Although, if you have pine trees, you can make your own. Same thing. If you make your own, it's natural, right? So you know what is in it because you're going to be breathing it. And it's just pine ember and just, rosin from someone making pine tar, local company. So it's all pine product. And I love no clean solder. It leaves behind some residue, yes, but it's no clean. Alright, so looks like we got some good connections there. Flush cutters. Cut it flush. Okay, and then we will go on to our final one. Just want to scrunch this in on itself as much as I can. Because after all, we're aiming 160 meters, right? Big boy stuff. Big boy band. Top band. And in case you're curious, as we're doing this, I'm working on dinner. Barbecue pork chops. What we're having, the YL, the fiance, the girlfriend, the young lady who lives with me, been together 2 years. She actually wound 2 of these toroids for me. And for those that are curious, she doesn't have her ham ticket yet. So winding toroids can't be that hard, especially if you're a man. You can let a female whip you when it comes to winding toroids. And she's not even an actual ham. But I taught her how to do it, and probably in about, I don't know, maybe 20 minutes, 30 minutes tops. And that was months ago, and she wound these for me today. I had to go back and recount the windings. You know, I only needed 35, she had 36 on them. So I had to go take one off, but err on the side of caution, you know. She really wasn't sure, so she gave me one extra rather than one less, and come up short. So we come up short. All right. Pop this one with the flush cutters. Bam. Bam. All right. So now I know that hit with the flush cutters, which would be 1, 2, 3, 4, 5, and 6. No, 5, 6. All right. So I'm just gonna continuity, curiosity. Okay. And okay. Now, for those of you that want to be super neat about stuff, yeah, you can take your 99% isopropyl for your board. Remember, this is no clean flux, but just because it's no clean doesn't mean you can't clean it. And clean your pad too, so that we have a good solid surface. Oh, let's see if I have to. No, we're good. Okay. So, remember, those up top. Position our board. We're going to flip these up. Just like that. Alright, we're going to flip those toroids up. That way we can get to our 2 solder points there and there. And I'll just use the flux pen here. Here. Okay. And in case you're wondering, I'm running at 701 degrees Fahrenheit. Alright, so we're just going to solder that. That's everything. Don't have to be too complicated. Just bridge it across. I mean, if you want to completely fill it with solder, man, that's on you. I'm just gonna pretend like I'm welding metal and just bridge up the whole thing. That way I know I have a good connection all the way across. With no cold spots or cold joints. And you normally know if you got a good solder connection if your solder is nice, bright, and shiny. That when I told you, hey, you've done good. Alright, so this is where we are at now. Okay. Alright, easy enough. And then we're just going to take these and we're going to push them down. Now, you don't have to worry about them interacting because, I mean, you do have an enamel coating on your magnet wire. But one thing I was looking at, and we're going to touch it real quick. I'm not sure if Chris needs us to do this or not, but I'm going to do it. I'm going to drop some flux. And then I'm going to come through and we're going to drop some solder on those center pins. Now they're connected. Even if I were to test it for continuity right now, we will find out that they're connected, but I want them to stay connected. I don't want them to come apart. But we'll check continuity with them. If I just touch the top of that, touch the board, and just like before. And if I make contact over here with that solder joint, center conductor, so they're supposed to have continuity. And if I did the same thing over here, okay, so continuity. What I want to do is I want to reinsure that, reinforce that. However, it might not be needed. So if you want to skip this part of it, you can skip this part of doing this, but I'm going to go ahead and do it. It would help if the iron were on. But I just want to connect there and connect there. And since I shut my iron off, I'm just going to leave it off. We're going to go ahead, we're going to put some solder on those two places, connect them. Just, it makes me feel good. So I'm not saying if this step is necessary, but if it makes you feel good, do it. It makes me feel good, that's why I'm doing it. And once we get through that, we'll come back and then we're going to go ahead and tune K4STV. Be back in a few. Hey guys, I originally was not going to film this part, but this is what I was talking about, you know, just a little bit of solder there, a little bit of solder there, just to ensure continuity. No big deal. So when we come back, then we go to my favorite part, tuning one of these. So grab your Nano VNA, calibrate it, or grab your Rig Expert and set it to 160 or wherever you built your filter. If you built it for 80, set it 80 meters. 40, set it for 40 meters. 30 meters, 60 meters, wherever. But this will be 160. And then we'll be right back with the tuning. Okay, welcome back. Seems like we got a little bit of a problem. Our board has been completely populated, what it should look like, and I should be able to adjust the SWR, but that's the best we can get. So before I went crazy, or before I went probing too deep and driving myself crazy, easy check. Break out your meter so that you have continuity. Yeah, so you can test for continuity. Alright. And we're going to go back and we're going to check a couple of things. I'm going to disconnect from my filter. I'm sorry, disconnect from my dummy load and disconnect from the Rig Expert. Our filter's oriented like this, and we're just going to test a couple of things. Number one, we know that right here on the top, right here in the corner from your toroidal core where you soldered it in, should have continuity with the center pin of the SO239. Get this in there. Okay, and on the other side, in the corner, you should be seeing continuity between and the center conductor. Okay, we spin these two up. So from pin to pin, there should be no continuity because you're going through your capacitors. So there should be no continuity. But ground, you should have it to the case. You should have ground to ground. You should also have ground to here. So ground, ground, ground. Have it to the case. Have it from here, there, but not to there. Well, I made contact with Tactical Radio Gear, and lo and behold, for testing purposes over a month ago, I got literally the first production board, or one of the first batch of the new boards, and out of the first batch of the new boards, there was a problem. They didn't run a trace to connect this to ground. So, simple fix, we saw what our SWR was. I'm just going to get a decent gauge of wire. I'm going to we use 20 for our toroids. So, I'm just going to use a piece of 16 gauge stranded. We're going to solder it in, and then I should be able to tune my bandpass filter. Now on the newer boards, or newer meaning the later versions of these, that problem has been fixed, so it should not be an issue. But if you encounter an issue where you have this really high SWR and you can't tune anything, check to make sure that you have some ground going to that spot. I can't find my auto snips, so I'm forced to use a different pair of snips. Let me take a quick look around. You know, I got a lab slash shack slash office that has everything and everything everywhere. And of course we're waiting on the good old soldering iron to heat up. While we're sitting here. But yeah, if you encounter that particular issue, check to make sure you have ground going to that particular spot. And if you don't have ground, that's why you can't get tuned. And like I said, it was a mistake. It got fixed. And hopefully too many boards did not make it out into the world that were not correct. Now I know what you're saying. Why didn't they test this ahead of time to make sure that when they were sold that people wouldn't be affected by the issue? Well, they tried. I received my package February 29th, and at the time I was dealing with a death in the family. I had to travel from North Carolina back to New Jersey, so I was not the ideal candidate or person per se to come in and discover the problem, because I had other stuff going on. So we've got a short piece of wire. I'm just going to trim down the edges with the flush cutter. Trim it up a bit and get it ready for some flux and some solder. And for flux, we're going to use, as usual, our Kester 186 to clean. Using a pen version of it. And there we go. It's looking good. As usual, soldering iron has been turned on, and we're at 701 degrees. I'm gonna reach up, gonna grab my mag set. I like to look close when I'm looking at stuff. Pop on some extra light. In case you all are wondering, I'm using a silicone soldering pad. It's probably one of the best things I ever have. It's very heat resistant. You can solder right on the pad without destroying it. And if it was any old rubber pad, this thing would have melted by now. And they're really easy to clean off. Just a little, spray just a little bit of 99% isopropyl and wipe it with a microfiber. You don't have to use a microfiber. I just recommend wiping it with a microfiber because microfibers don't leave behind a whole bunch of residue. I'm just using a flush cutter just to trim up the ends of this. So my first solder point, I'm just going to lay this in here. I'm going to go to that connection right there underneath the center toroid. Now for those that don't know, center toroid controls frequency. You know what? I don't want to spend too long heating this up. Drop some flux. Drop some flux. here and get the solder flowing. There. Okay. So we got a good connection there. And I'm just gonna pull that wire back. I'm not gonna trim it anymore. It's fine the length that it is. That's where I want it right there. I'm gonna take the flux pen, get some flux on it. Negative pad right there. And again, I use Kester, no clean flux. You can clean it if you want to. You don't have to. And we're just going to come down. And we're going to drop the big old 700-degree iron on this joker. I should be using a broader tip. Sometimes I think this iron's on its way out the door. You know, when I say on its way out, sometimes it gets left on and it's on for 24 plus hours on a high heat setting. It ain't burnt out yet. Not to mention, relatively cheap. I'm going to drop in some flux because I should have put a broader tip on this. Because a small tip trying to transfer all this heat equally over a relatively large area. Ideally, I should be using a larger tip. And folks, I think we might be on the way to having to purchase a new iron. Because this isn't acting like an iron. It's at 800 degrees almost. Should see puddles of solder about now. And what I don't want is I don't want to cold the solder joint. Because that only means we'll be back in here at a later time fixing something. Crank the heat up on this a little bit more. Okay. All right. So, like I said, to get rid of your flux, this is 99% isotope. Spray some in the area where you got it, and just take a rag and just wipe it clean. There you go. All right. So now, again, we will test for continuity. And we're going to test from ground to ground. So from here to here, continuity. From here to here, continuity. Good. Go ahead and lay that tool right back down. Lay that tool right back down. Now, someone can't say smoke and mirrors. I'm going to zoom out. Out. We're just going to connect. Now remember, we were like at 14 SWR earlier. Going to connect our dummy load on one end of our filter and this into the other end of our filter. And now that we have ground, we have, I don't know if y'all could see that. Zoom in. 1.10 SWR. That's fine with me. I might play with it just a little bit to see if I can get it to pop down here in the band, but I think is going to be as good as we can get, because I mean 60 meters is very broad. .08. Don't have much room for pulling turns on toroids right now. 1.07. Okay. It was resting against the capacitor. There we go. All right. 1.045. lines aren't crossing. I do like to see it bumping it or bumping stuff around. Changes anything. Alright. Okay, so tuning your SWR like I normally showed you how to do it. We're at 104, 105. And that's at 1900. So that's pretty much the center of the frequency. I'm going to, at this point, attach the case. And we're going to call this done. Now attaching our case sometimes will affect SWR. Trying to see if I got a cold joint in here or maybe a loose connection somewhere. Just making sure my coaxial cables are behaving like they're supposed to. Alright. Having interaction with it. Okay. Now you do realize if you have interaction with your case, your SWR will jump around a little bit. So this is, well, I'm going to say pretty much isolated. I'm holding it. So I've, in a sense, become part of the ground because our case is grounded, right? So, alright, we're going to wrap this up. I'm going to set the frequency to 01800. So down there we're at 1.14, 1.13 SWR. And we're going to climb all the way up. And we're going to go all the way to 2000. So we're going to start at the very bottom of the band, come up to the very top of the band. And as we get up to, stop moving around, we get up 1.2 to 1 at 987 and 1.2 to 1 at just over the 160 meter band. So for filter, we're pretty much good for the whole band. Well, that wraps it up with 160 meter bandpass filter using a new board and new kit design. I hope you guys enjoy it, and if you encounter that problem, there's your fix. This is Kilo 4 Sierra Delta Victor saying peace till next time. You guys stay cool, and if you're in a cool area, stay warm. Goodbye.